Hello, welcome back. We're gonna continue on in Unit 3. Same relationships going on today, but today they're gonna take a mathematical component with them as well. So, if you remember back in 3-1, we were talking about two lines. We had two lines, and then we had a third line that was cutting across both of these. All right, and what that did is it created, and that line, by the way, was called a transversal. Transversal means cutting across. So we had these two lines cut across with a transversal, created 8 angles, and then we really focused on the relationship, like the group of 4 angles pertaining to this line had some kind of relationships with the 4 angles created down here with this line. So today, the only difference now is these two lines are going to be parallel to each other. All right? And so when these two lines are parallel to each other and you cut them with a third line, those 4 relationships are still there, but now they take on a mathematical aspect as well. So that's what we're going to be spending the bulk of our time today. So those same 4 relationships, same side interior, alternate exterior, and corresponding. Still talking about them and going to be talking about them in lesson 3 as well. They're still the same ones, but now the mathematical component kicks in. So let's just jump right in and start. Oh, before we do, for those of you all wondering about the next test, it's going to just be on these 4 relationships that I just mentioned. It's a shorter test as we're getting close to the end of the quarter. It's just going to be on lesson 3-1, which you all did online. Everybody did because it was an e-learning day. Then today's lesson, and then 3-3 again just kind of wraps up these same angle relationships. All right, so here we go. We're in Unit 3, Section 2, properties of parallel lines. So those 2 lines have to be parallel today for this stuff to work. And there's that one of the relationships we talked about the other day, same side interior angles postulate. All right, so when you have the 2 lines parallel this time, see the red arrowheads that makes them parallel, and they're cut. You've got 2 sets of same side interior angles. You got angle 4 and angle 5. Those are same side interior buddies. And you got 3 and 6 are same side interior buddies. Their mathematical relationship is the one that when you add them together, they add up to 180. That fancy word supplementary. All right. So same things with 3 and 6. They add up to 180. And see, 3 and 6 are same side interior. 4 and 5 are same side interior. So take a few seconds to copy that. I'll pretend like you did, and we're moving on to the next screen. All right. So same side interior has the 180 relationship. Okay. The next 2, alternate interior and corresponding angles, they have a congruent or equal relationship. All right, so go ahead and jot down that real quick. And if we're talking about alternate interior first, if I pick on angle 4 here, his alternate interior buddy, just to recap, the only ones I have labeled right now are the interior ones, the ones inside the lines, right? So those are the inside angles. I don't have any of the exterior angles marked in this picture yet. I'm going to in a moment. So looking at angle 4, his alternate interior buddy would be 6, right? Because remember, we talked about every angle up here has one of the relationships with these guys down here. 4's alternate interior relationship would be with 6, because remember, alternate kind of is like the word opposite. 4 and 6 are on the opposite sides of the transversal. Here comes the transversal. 4 is over here on the left, 6 is on the right. So they are the alternate interior buddies. And then likewise, 5 and 3 would be alternate interior buddies. And they have a congruent or equal relationship. So whatever angle 4 is, say it's 75 degrees, then you now know angle 6 has to be 75 degrees if these are parallel. And they will be throughout today's lesson and next time's lesson as well. All right. Corresponding. I need to add some numbers here. I'll just go ahead and continue this 3, 4, 5, 6, 7, 8 numbering pattern, I guess. So in this situation, if we pick on 4 again, he has a corresponding buddy down here in this group. Remember, corresponding from last time, if you remember, it's a fancy word that means matches up with. So who does angle 4 match up with in this group down here? Well, if you look at this group of 4 angles, 4 is in the bottom left corner, so he's going to match up with whoever's in the bottom left corner of this, and that would be 8. All right? And so corresponding also has an equal relationship. So again, and I think I said 4 was 75 degrees, I think that's what I said. That means angle 8 would also be 75 degrees. So Mr. Metcalfe, you're saying if angle 4 is 75 degrees, 2 of the guys down here have to be 75 as well? Absolutely. Absolutely. All right, moving right along to the last of those 4 new relationships, and that's alternate exterior angles. If I go back to my drawing, let's see, how did I have those numbered? I know I had, we'll put a 1 here. I think I had 4, 3, 6, 5, 6, 8, 7. I think that's who I had. So who alternate exterior, again, it's another congruent or equal relationship. So I can't talk about angle 4 this time because he's not an exterior angle, is he? 4 is on the inside. So I'm going to change and talk about angle 1. Who would angle 1's alternate exterior buddy be in this situation? So he's got to be somebody else who's on the exterior. So it's either got to be 8 or 7. And then the word alternate means the opposite side of the transversal. So if 1 is on the left-hand side of the transversal, his alternate exterior buddy is going to be somebody on the right-hand side of the transversal, which would be 7. So 1 and 7 would be alternate exterior buddies, and they are, again, equal or congruent. So if angle 1 happened to be 105 degrees, then so would angle 7 have to be 105. They always have an equal relationship. And now we got a Metcalfe corollary. Now that means a Metcalfe corollary means it's not in the book. If you were to look it up, but it's still true. It's just I don't know why they didn't put this little helpful hint, but it says if parallel lines are cut by a transversal, that's just given in today's lesson. We're always going to have parallel lines cut by a transversal, then 4 of the angles will be congruent to each other. So 4 of the 8 that are created will be equal to each other, and the other 4, they'll be equal to each other, not equal to the other 4. I mean, it's possible. There's one extreme example where they could all be equal, but they will be supplementary to the first 4. So 4 of the angles, I think I used the example, they were 75 degrees, then the other 4 angles would all be 105 degrees because 75 and 105 makes 180. So 4 angles are 75, 4 angles are 105, and added together, that makes 180. So bam, that's what the Metcalfe corollary is saying, just trying to make it easy for you. All right, moving on. And here's a little summary of this lesson, all right? So again, the lines have to be parallel for this to be true, but here's the 4 relationships. 3 of them are equal relationships, and then here's the oddball, same side interior. He's the one, they don't equal each other necessarily. I mean, obviously they could, 90 and 90, they could be 90-degree angles because that adds up to 180. So same side could be equal, but it almost never happens, all right? They always, though, add up to 180, all right? So just a little quick, almost like a cheat sheet to help you summarize what we've learned so far. Bam. Okay, moving on. Now we're going to do a couple of problems to make sure you got this. So the first one, I'll give you a few seconds, pretend like you've drawn the picture. It says if angle 3 is 55, so here's angle 3, I'm going to go ahead and put a little 55 next to him. Then which angles are supplementary to 3? Okay, so we don't want the ones that are equal to 3. We want the ones that are supplementary. So we learned the one relationship that is supplementary is that same side interior relationship. So who's his same side interior buddy? Well, we're talking about these guys on the inside. His same side interior buddy would be 8. So 8 would be supplementary to him. So I'm going to write SUPP for supplementary. He would be supplementary because of the same side interior angle situation. And then who else would be supplementary to him? Well, in this group, another way to be supplementary is an old school relationship we talked about, linear pairs. Remember, 2 angles on a line? You have that situation like that. You have pretend like my arm's a line, and then here's making 2 angles, one over here and one over here. Those got to be supplementary. So 3 and 2 are linear pairs with each other. So 2 would be supplementary to 3. And then if you use this as your line, 3 and 4 are next door neighbors on a line, so they're linear pairs together. So they would be supplementary to 3 as well. And that leaves, which other? Is there one other one? Because Mr. Metcalfe told you there would be 4 that are 1 degree, and then there'd be 4 that were another degree. Well, the only other one, he's got to be one down here, and you see that beautiful X. And whenever you see a beautiful X, you should be thinking vertical angles. So if 8 is a correct answer, 6 is vertical with him. So therefore, that means 6 must be a correct answer. So the angles that are supplementary, not equal to, they don't want that. They want supplementary to. The ones that are supplementary to 3 would be angles 2, 4, 6, and 8. Those would be the ones supplementary to angle 3. All right. Any questions on that? If there is, shoot me an email or come to our Google Meet. By the way, speaking of Google Meet, for all you sophomores and juniors out there, we're going to have our first Indiana Gear Up Google Meet this Thursday from about 3:30 to 5:30. You know, you don't have to stay the whole time. You can pop in when you feel like it, and we're going to answer questions, just check in with you, see how you're doing. I'll send out the Google Meet code for that here in the next day or two. But yeah, here we go. Moving on. I'll give you a few seconds to draw this picture. We're only going to do like maybe 3 or 4 of these. Again, what they do is sometimes they make the drawings more complicated to try to see if you to kind of hide the relationships we have. So now we've got almost like a tic-tac-toe board going, and the only angle they tell us is 105. All right, so that's going to be our reference base right there. Okay, so 105. Believe it or not, since you see a double arrowhead, that means these 2 lines are parallel. And you see a single arrowhead and a single arrowhead, which means those 2 lines are parallel. So you won't believe this, but knowing that one angle is 105 and that both sets of sides are parallel, you could find all 15 other angles. Matter of fact, half of them are going to be 105. The other half of them are going to be whatever number makes 180 with 105, and I think most of y'all know what that is. So yeah, you can find out what every other angle. Now I don't have all 16 of them marked. I think I just have 8. Yeah, 1, 2. It looks like it goes up to 8. We're only going to do a couple of them because I think you'll get the picture pretty quick. So what does angle 3 equal? If this angle right here is 105, this is going to be our base of reference right here, that 105. Well, if you look at angle 3 and angle 5, they're talking about in between these 2 parallel lines, so they're interior. You know, you got the interior part, but they're not on the same side. They're on alternate sides. Like he's on the left and he's on the right, so they are alternate interior. That's going to be my justification. Alternate interior. An alternate interior, if you go back to that one previous screen, that is a alternate interior is an equal relationship. So if he's 105, so is angle 3. So angle 3 is 105 degrees, and my justification is because they are alternate interior angles with each other. All right? So far, so good. Now, what's angle 4 going to be? Okay, angle 4 and angle 105 also have a relationship. we're now talking about these parallel lines, not those, because this line right up here has nothing to do with angle 4. So we're talking about these two. Again, they're on the inside, they're interior angles, but this time they're on the same side of the transversal, right? They're both on top of the transversal, so they are same side interiors, same side interior. And that is the weird relationship. That's the one that's not equal necessarily. It's the one that adds up to 180. So if he's 105, what makes 180 with 105? Well, I think most of y'all know that would be 75 degrees. So he is 75 degrees because of the same side interior angle postulate, right? That's my justification. All right, I'm going to bounce up to angle 1. So you're saying, man, Mr. Metcalfe, I thought 105 only had relationships with these and these. Technically, yes, but the fact that these are all parallel, then I can make the jump from here to now. I know this guy is an absolute fact. He's a 75, and this guy can make the jump to angle 1. And again, if I'm talking about angle 4 and angle 1, they are inside. And again, they're on alternate sides of the transversal. So this is a alternate interior relationship. But I'm going to put, it's not with the 105, it's alternate interior. I'm going to put with angle 4. All right. So 1 is alternate interior with angle 4. And remember, alternate interior is an equal relationship. So he will be equal to angle 4, which angle 4 is 75, so is angle 1. All right, so I'll put a little 75 there, and I am already out of calibration. Just calibrated right before we started this lesson. I'm going to do it again real quick because, I'm a little bit off. I'll try to do another screen first. Maybe I can make it work. So any question on that? Here's a few more you all can try. And again, it's really good to label the ones you know for sure. Once you've shown or proven that you know what they are, then you can use those as base reference. Just tell me when you do your justification, like why you're saying that angle is, like why. I mean, I said angle 1 was alternate interior, but not with 105. He was alternate interior with angle 4. So let me know that kind of thing. And you got a few more you can practice yourself. All right, moving on. Okay, now since this concept is pretty easy, sometimes they try to make the diagram more complicated to hide the two parallel lines in the transversal. So what you need to do is you always need to look for those parallel lines. Well, in this one, they indicate these are the two parallel lines. So this guy's the transversal. Technically, he would be a transversal as well, but I don't really know any information about the angles down here, so I can't really use that one as a transversal. I'll be using this one as the transversal. And if I do, this 80, he's on the same side as this y and 40 combined. Not just with the y, not just with the 40, but the y and the 40 combined has a same side interior relationship with 80, right? And again, that's the weird one. I'm going to call it SS int, same side interior. So that means this 80 and these two combined have to add up to 180. So I think most people know if this one's 80 and these guys combined have to make 180, then this combo right here, this combo, not just the y, not just the 40, but combined has to be 100, right? Because 100 plus 80 makes that 180, all right? Well, you all are saying, well, it's easy now that you reminded us of that. Hopefully you figured that out on your own. But if this guy here is 40, therefore the y has to be 60 to make that 100 degrees. So y is 60, all right? And you're saying, but Mr. Metcalfe, 60 and 80 don't make 180. That's right, because y is not the whole same side interior angle with 80. Y is part of it with 40. Okay, now here's another one where they've tried to hide the two parallel lines cut by a transversal, but again, they're not allowed to hide them too well. They got to let you know who is parallel. Obviously, these two guys are not. This one's kind of pointing up to the left. This one's kind of pointing up to the right. But these two guys are parallel. So if it helps you to do this, go ahead and indicate. Extend them if you need to. So here's the parallel line. Here's the transversal coming down like that. And that might help you see which relationship we're talking about. All right. So I'm going to give you a few seconds to draw that. I'm not going to stop. I'm just going to go ahead and calibrate while you all are pretending like you all are drawing that at home. All right. I'll try to do this quick. So my pen is functioning properly again. Awesome. Okay, so I think when I extend those lines, you see these are the two parallel ones. We're going to ignore this side for the time being. We're just talking about this kind of situation over here. So here's my parallel lines. The 2x and the x minus 12 are both over here to the right. So that is a same side interior relationship, right? That's the weird one. That's the one that's not equal. That's the one where they add up to 180. So we're going to say 2x plus this angle down here, his same side interior buddy, x minus 12, that has to add up to 180. Is everybody seeing that? Because that's the whole geometry part right there, is seeing that that's a same side interior relationship and knowing that that relationship is 180. All right, so same side interior, and it's a 180 relationship. All right, the rest is algebra 1. You got 2x and ghost 1x. That makes 3x. Minus 12 still equals 180. And I'm pretending like you all paused and already worked this out, and you're waiting to see if your answers are correct. By the way, there's a lot of answers. They want to know x and y and then all four of the angles. All right, so hopefully you paused and you're working that out at home. All right, so we're back. And we're going to solve this 3x minus 12. We're going to add 12 to both sides. And it cancels out, so you got 3x equals, that's going to be $1.92. And then we got to get rid of this times 3, so we divide by 3, and we get x equals. Now, on a test, I'd want you to use a calculator for this, but then since this is a lesson, let's go ahead and do it with our brain. 3, of course, won't go into 1. But 3 will go into 19 about 6 times, which is 3 times 6 is 18. So there would be 1 left over. And then 3 goes into 12 exactly 4 times. So x is 64. And then that's going to help us find these two angles. So if we want to go ahead and do that, we can. I'll skip over y for a second. We'll go down to angle B. Angle B is 2 x's. Well, if x is 64, then this is going to be 2 times 64, which I think most of you all know is $1.28 degrees. So angle B is 128 degrees. Now, there's 2 ways to know angle E, and again, I'm skipping T to go to E because I'm dealing with the X ones first. There's 2 ways to figure this one out. You can do the algebra way, saying, okay, x is still 64, right? Yep, it sure is. 64 minus 12. That would be 52 degrees. But then you also know, hey, Mr. Metcalfe could have saved a little bit of algebra by saying, if this guy's 128 and he's same side interior with this guy, he's got to be whatever number makes 180 with 128. And again, that's 52. All right. So there you go. So we've taken care of the x's and the left-hand side of this weird shape. By the way, first period knew what this shape was called. They said they've learned that already. I haven't taught it to you yet, I don't believe. We don't get into quadrilaterals too seriously for another chapter or so. But you got the same deal going over here. Here's my 2 parallel lines. And if it helps you to see it, you can extend this. That would be your transversal. These guys are on the inside. They're on the same left-hand side of the transversal, so it's another same side interior situation. So just like these two guys had to add up to 180, these two guys have to add up 180. So I'm going to say 3y plus y plus 20 equals 180. All right? So this angle plus this angle, since they're same side interior, has to add up to 180. I've got a 3y plus a ghost 1y. That makes 4y plus 20 equals 180. And again, hopefully you have paused this at home and you did the answers yourself, and now you're waiting for the explanation. So most of y'all would have subtract 20 at this point, and you would end up with 4y equals 160. And then divide off the 4, and you get y equals 4 goes into 16 exactly 4 times. 4 goes into 0 exactly 0 times. So y is 40. So now all the heavy lifting's done. You just got to plug that 40 in here, and you have the other two angles. And they should add up to 180. All right? So if they don't, you know you did something wrong. Well, 3 times 40, remember he's 40 now. 3 times 40 is 120. So angle T is 120. And then again, y is still 40. 40 plus 20 is 60. So this angle is 60. And sure enough, 120 and 60 make 180. Just like 128 and 52 made 180. All right. Awesome. Any questions? I think we're about done. I think that all that's left is a little kind of wrap up. We'll take a look at it. Oh, here's a visual representation of the Metcalfe corollary, visually. So here you go. And again, this only works if these two lines are parallel, which they are with the arrowheads. So if they're parallel, some cool things happen. And I've color-coded it and made it symbols and stuff. You have the 8 angles. 4 of them will be the same. So you see I got 4 green stars, these two and these two. They'll always be the same, equal each other. And then I've got 4 of these yellow asterisk things. They will always be the same as each other, all right? So you got 8 angles, 4 are the same, and the other 4 are the same. And then here's the beauty of it all. These 4 that are the same and these 4 that are the same, when you add together, an asterisk plus a star would add up to 180. So if you know one angle, you can use your brain and these concepts we just learned today to find out the other 7. And I do believe that's it, except for I think I got a little wrap up on this next slide. Here is a little summary of what's going on. Here's the 4 angle relationships we just learned this chapter. Same side interior, that's 180. Alternate interior, that's an equal relationship. Alternate exterior is also an equal relationship. And corresponding, there's the one where they match up. That's an equal relationship. Then just a reminder, these guys are not going to go away. These are some old school. We got the perfect X, so we got vertical angles, all right? Vertical angles, they're always an equal relationship. And then next door neighbors on a line, all right? That's not going to go away. That's called a linear pair, and they also add up to 180. So in the old school relationships, we have one that's an equal relationship and one that's a 180. So just to sum it all up, those 4 relationships, when the lines are parallel, some cool mathematical things happen. 3 of those relationships are equal relationships, and then the one oddball, same side interior, that's a 180 relationship. All right, homework coming up should be online in a few minutes. And our next test, we got one more test. It's just going to be over the first 3 sections of Unit 3, and it's these 4 angle relationships that you just got to know. Pretty easy test. That I'm looking at today's Monday when I'm videoing this. So we got one more lesson that you all will knock out on